Hi, so today we're going to look at the reaction of oxygen with various elements, some metals, some non-metals, and we're going to put the oxygen in here. This is a gas jar and that is a cover lid. And if I put oxygen in there, I can try and react whatever it is by putting it in one of these things. Deflagrating spoon, if I plunge it in there, hopefully if that's got oxygen in, there will be a reaction between the element I put on the spoon and the oxygen gas itself in the jar. The problem with this is some of the elements need to be really hot, and I can't get them all really hot reliably every time. So some of them may not work as well as we expect, but let's see how we go. And the pattern I'm trying to teach you is that the element will react with oxygen and it will make element oxide. So let's see what we can do. Before we start then, I want you to understand that this is a gas cylinder, and the gas cylinder has got oxygen inside. There, oxygen's coming out. If I put that in there, it's pushing out the air. As the air gets pushed out, cover slip, and turn the oxygen on. So, jar of oxygen. Well, how do we know it's oxygen? We can prove it's oxygen with a glowing splint. The glowing splint should relight. Look, that's glowing. You see? Look, in a test tube, you can only really do that once. With a test tube, you can only really do that once. With a gas jar, obviously, because there's a lot of oxygen, you can do it multiple times. So that proves that I had oxygen in there, and I got it from the gas cylinder, so I'm going to fill it up again. Now, filled up again. Can we go over, before we start, the properties of oxygen gas? Oxygen gas is colourless. Look, no colour, colourless. Oxygen gas is, smell it, odourless. It's got no odour, odourless. Density, the density of it is just a little more dense than air. If you go up Mount Everest, the proportion of oxygen is a bit less at the top of Mount Everest. And down here at the bottom, near sea level, the density of oxygen being a bit more means that the proportion of oxygen is a bit more. So 21% here, I don't know what it is at the top of Mount Everest, but it'll be a bit less. Solubility, dissolves in water. Of course it dissolves in water because fish and aquatic life need oxygen to do respiration, and they get it from the oxygen that's dissolved in the water in which the aquatic organisms live. Litmus. Now, this is universal indicator. It's not litmus, but it's universal indicator. Can you see it's green? And if I put some in there, and I shake it up, that stays green. Right, so let's fill this up again. And one of the reactions we can do is to burn magnesium. Now we can burn magnesium in air, and then we can compare it to burning in oxygen gas. So this is magnesium in air. I've got here magnesium, burn it. There, bright white light. Do not stare into it. You can glance at it, look away, but don't keep looking at it. It's dangerous. What you're left with is a white ash. You can see that. Now, compare that with me trying to do it in an environment of oxygen. Now, this is a cheap gas jar. Sorry, a cheap jam jar. Because the hot magnesium, when it's burning, might melt it. So I don't want to use an expensive gas jar. I'm going to use a cheap jam jar. Let me fill that with oxygen. There. That's got oxygen in. Right. Now, what I'm going to do is to get this magnesium burning, and then I'm going to plunge it. I'm going to plunge it into this jam jar of oxygen. And now you should see a better burn. Better than you saw last time. Here we go. So, magnesium is burning, and now watch. You can see the white ash that's left. The white ash has covered my my tongs I was using, but that white ash is magnesium oxide. So magnesium with oxygen makes, believe it or not, magnesium oxide. That's magnesium oxide. Right. Well, how about a non-metal? Let's do a non-metal. Let me get fresh oxygen in here. And the non-metal I think I want to do is one of my favourite, sulphur. Now I've got deflagrating spoon here, sulphur here. If I fill that like that, look, sulphur. Now I'm going to keep the lights on, but I might do it again with the lights off. Watch. I need to get the sulphur hot and burning, and then I'm going to plunge it into the oxygen. There, it's burning a bit. Watch. See that blue flame? The sulphur burns with a blue flame. So what's happening there is sulphur with oxygen. It's making sulphur dioxide. Now I want to test sulphur dioxide with some universal indicator and water mixture here. So if I just take this out for a minute. Shake it up. Look, that's orange. So that's acidic. That's the idea of acid rain. When you get sulphur oxides in the air, they will make rain, when it rains, acid rain, because the oxides dissolve into the water. So these are the oxides dissolving into the water there. And when they do, they make acid. mixture, it is in fact sulfurous acid. So sulfurous acid that's made is not quite the same as sulfuric acid. It's H2SO3, whereas sulfuric acid is H2SO4. The H2SO3 is a weak acid, and this weak acid is what causes acid rain, and that's really what's going on there. Now, really I want to do that again, perhaps with the lights off. So, let me go and turn the lights off first. It's only about 4 o'clock, so it might be that there's too much light here. But let's try it. So, we get oxygen. Cover slip. Make sure I've got oxygen in there. I'm going to get some sulfur again. Melt the sulfur. Get the sulfur hot and burning, and look at that. That is a lovely blue flame. Gives off sulfur dioxide fumes which are acidic. Now the sulfur oxide fumes will stay in there because I've got the lid on it, but you don't want to be breathing them in. As you breathe them in, they would make weak acid in your lungs, which is not particularly going to be good for you. But seeing as though these videos don't expose you to these dangers, then we can watch them on video without you being at any risk whatsoever. I think that's the realization I'm coming to with these videos that I'm doing, which I quite like. So that is sulfur burning, making sulfur dioxide. Now all of these, I want you to be able to write equations for them. And the equations, let me see if I can show you the equation I need you to know. The equation I want you to know is that one. Burning elements. An element with oxygen will make element oxide. Now that is what we call a general equation. And what I want you to do is, with these examples, I want you to write word equations, like sulfur plus oxygen makes sulfur dioxide, and then I want you to turn those into symbols, symbol equations, and then I want you to balance them. I want you to finally end up with balanced symbol equations, because that's the skill that you need, balanced symbol equations. Get practicing them, get writing them, get them correct, check them with your teachers, etc. Right, so a couple more things I want to show. I was hoping for some pieces of copper, and I haven't really got any. I've been given copper turnings, which are teeny weeny pieces of copper. Perhaps if I stick them in a test tube. 1 minute, let me get a test tube. Now, I've got a test tube here. Get some copper. See? I've got some copper pieces. Copper is, believe it or not, a reddish brown colour. For the sake of me, I'll never know. Why can't we call it copper coloured? But all the books say reddish brown. To me, copper is copper coloured. But the description is reddish brown solid. So reddish brown solid, and I'm going to heat it. Now, if you heat it, then it's a bit damp. So it'll take a little bit of time for the dampness to disappear. I'm going to get rid of the dampness. I hope you can see. That's a dry test tube. And then the copper will start to react with the air that's within the test tube, and as it reacts with the air, then it starts changing colour. You see what colour it is? It goes darker, it's going black. Now that's on the way to being black. If I heat it more, be careful not to point test tubes at people. You want to point them away from people in case the contents eject themselves out of your test tube. Luckily there's nobody else here, there's just me. I'm just making sure that they're pointing away from me. And there, you can now see that what you've got is black, a black solid. Black solid, black solid. The black solid is copper oxide. So you know we said copper doesn't react, but it does react with oxygen. If you get fresh copper pipes, then over time those fresh copper pipes go kind of like a dark colour. That's the copper oxide on the outside coating it. And if you kind of like sandpaper that away, underneath will be fresh copper, which will be copper coloured or reddish brown colour. The blackness, the darkness, is copper oxide. Now this is a reaction we're going to use later. We're going to use that to prove what proportion of the air is oxygen. And that's because I'm going to use copper to react with the oxygen, take the oxygen out and see how much air is left. But that's for another different practical we'll do some other time. So copper and oxygen make copper oxide. Copper and oxygen make copper oxide, magnesium and oxygen make magnesium oxide, sulfur and oxygen make sulfur oxide, but there's a few sulfur oxides, so we say sulfur dioxide. We can try all kinds of things like carbon and try and get carbon dioxide, but I've not been given any carbon. Haven't got any carbon here, so let me just do what I have got here. How about sodium? Now, sodium is kept in oil because it's a very reactive element. And I'm just going to grab a piece using some tweezers. Oh, dropped it. Grab a piece. Perhaps grab two pieces. I got a tissue. I'm going to dry the oil off using the tissue. I'm going to get a deflagrating spoon. There, deflagrating spoon. I'm going to put the sodium in the bottom of that spoon. Hope you can see it there. I'm going to make it get hot and it will burn with a yellow flame, and then I'm going to plunge it into oxygen. Let's get that jar ready of oxygen. Jar of oxygen. And I'm going to see how sodium will react with oxygen. The problem with this is because the spoons are kind of rusted, then the sodium will start to react when it melts with the crap that's on the spoon rather than with the oxygen like I want it to. So I know sodium burns with the yellow flame. Let's get it burning. It's not burning yet. How about heating it from the top? Burning it, get it to yellow flame. Oh, come on. It's not giving me the kind of, I'm going to try and plunge it in and hope the oxygen starts it going. There. That is sodium burning. Sodium burning, in there we'll get sodium oxide. So sodium gives sodium oxide, etc. Now, there's just one more. If I can find some phosphorus, I'd like to try and do phosphorus. 1 minute. Now, phosphorus. I need a defecating spoon. And phosphorus I'm going to put in this. I'm going to fill this jar with oxygen, a flat bottom flask. So there I have my oxygen, and I'm going to put phosphorus on this defecating spoon. This is phosphorus. Now phosphorus is kept in water because it reacts when it's dry. But we put it in water, keep it damp. As long as it stays damp, it doesn't react. Now, there, I've got some sulfur. When that, sorry, not sulfur, phosphorus. When the phosphorus becomes dry, it will start to react. And hopefully I can plunge it in there and get it to react in the oxygen gas. So I'm just going to get it dry here. Now, isn't that fantastic? Now, one extra thing I'm hoping to teach you is with these indicators, phosphorus is a non-metal. And what we made there is phosphorus oxide. When we have a non-metal, its oxide is acidic. Non-metal oxides are the acids of our world when you put water with them. I can show you that with, look, I've got some universal indicator and I pour it in there and I can shake it up. The phosphorus oxide is a white solid. So all this stuff is the phosphorus oxide I've made. And can you see the phosphorus oxide is indeed orange with indicator, and that's acidic. Do you remember the sulfur? That was a non-metal, and that made an acidic oxide. Carbon with oxygen makes carbon dioxide, and carbon being a non-metal, carbon dioxide is acidic. So non-metal oxides will give you acidic compounds, whereas metal oxides will give you alkaline compounds. If you remember, this was where I burnt sodium in oxygen, and sodium in oxygen makes sodium oxide, and sodium oxide should be alkaline. So metal oxides are alkaline. Watch, let me take that off, put that in there, shake it up, see if I had enough made. See a hint of blue? I'm hoping that you saw a hint of blue. Let me just shake it up again. I think the oxide was on the defrigating spoon. So when it dissolved, can you see, you get the alkalis of the world. So the alkalis are metal oxides and metal hydroxides. The acids are the non-metal oxides. Right. Just trying to think if there's anything else here I can show you. Sulfur, magnesium, copper, phosphorus, sodium, copper. I think that's it. I don't think there's anything else. So the main thing is, I want you to enjoy your chemistry. Main thing is, enjoy the chemistry and learn the patterns. What pattern today? Element and oxygen makes element oxide. Watch that one. But then I also want you to learn this one. Now this is for the next video. I want you to learn that compounds will burn. When a compound burns, you get a mixture of the oxides of the elements that make that compound up. Right, that is for next time. Okay guys, take care. See you next time.